Most of our activities in this project were focused on I'd say developing, but it's sort of revising the fruit growth rate model that Dwayne Green and others had developed, attempting to make it easier to use so that we could get a little more adoption in predicting fruit set. This was the work of Laura Hillman's PhD thesis, and she did defend that successfully just a month or two ago. And she's moving on, getting on a plane in 2 days to go to New Zealand, where she has a research appointment there. So I'm really grateful to the project, to Terrence's leadership, allowing us to contribute and develop this work. It's really it's really strengthened a lot of my thinking about my own research program and what I see as useful and valuable and how I want to proceed. And I've forged a lot of very nice research collaboration. So I've shown a lot of the data in the past about this project. And what I'd like to focus on today is more or less a sort of how to enact this model of ours. At the risk of redundancy and boring myself and others who have had to sift through all the data, I'm going to take a different approach. As Terrence mentioned, the group that did this work was at Cornell, North Carolina State University, Washington State University, and here at MSU. At MSU, we used, in Michigan rather, we used a lot of growers, and they helped us quite a bit in the collaboration over the years. And we did this work for 3 to 4 years. And we just recently published our work. Let me just get this out of the way. In a couple months ago, and it summarizes the several years of findings, the comparisons of models. And so if anybody is at all interested in the nitty-gritties of the work, you can find this publication online and get that. In terms of setting up this model, okay, we created, Laura and myself, a sort of how-to guide, okay, and that was published on the PACMAN website, and you can navigate to it. It's the fruitlet size distribution model. This is an updated version of the post. And I just want to point out that we're submitting this how-to guide and a manuscript for the Fruit Quarterly Journal that will be coming out, I suppose, in the spring or late winter, early spring of this year. I can't recall the cycle, but my due date's January 26th. And so what I present today will be in a nice written form if you want to have it at your fingertips. The way that we developed the model and the way that we intended it to be used, and it's sort of panned out, is as follows. We suggest that you count a total number of flowering clusters on 5 trees. We suggest you collect 25 clusters and count the total number of flowers on those clusters. And then you tag 3 sets of 40 clusters, so 120 clusters from representative trees that you're going to collect at 3, 6, and 9 days after a thinner application. And again, this is a guide to predict fruit set or abscission after you apply chemical thinners so that you can put another application on before the window closes and you're stuck hand thinning. I highlighted this in red because midway through the process, we tried to change this step and just suggest that you go out at these 3 different times, 3, 6, and 9 days after thinner application, and collect 40 clusters that you're going to analyze or quantify the fruitlets on. And what that led to an overestimate of fruit set because we were all biased to grab clusters that had fruit, thinking we needed to measure the fruit. And therefore, we weren't incorporating blank clusters. And that was one of the errors in the thinking, though we were attempting to increase efficiencies. So what we realized is our earlier work, we never did that. We tagged the clusters at bloom, and therefore we've firmly estimate any blanks that may occur because they've already been tagged. So you need to tag those 40 clusters or 120 at the beginning. Then you enter data into the Excel sheet. And the way this looks is, this is all part of the post that we put on the PACMAN website. It's an Excel program with all the macros embedded. All of the yellow cells you have to enter. So the number of clusters on the 5 trees you counted, the number of flowers, and then of course it estimates the average number of flowers on 25 clusters, the number of target fruit that you want. And this is not yellow because we suggest 40, but you're welcome to do 50 or 60. I don't think you're going to want to do more. But if you do, we've left sufficient cells to allow you to do those calculations in the other data sheets of this file. You have to enter the dates because these are the dates you sample and the dates of the last thinner application that all of the data are based on in terms of the output. This is sort of like a log that you can use if you want to add some extra information to guide your thinning over the years or see what you've done. Okay, as you go, then you're going to collect these 40 clusters at a given sample date, 3, 6, and 9 days after application. You can remove all the fruits from the clusters that you're gonna weigh, and you don't have to have the pedicels attached, but we suggest that to be consistent, you either remove them always or don't remove them always. Then you're going to weigh each fruit individually. There's no sorting or logging of the actual fruit with its spur or cluster or anything like that. It's just the total number of fruit individually weighed from the 40 clusters. In that protocol, we recommended a scale. It's just a recommendation. There are other brands of scales that are useful and would serve the purpose. Ours, the one we've suggested, it costs about $500 and it automatically exports data to Excel so that it can be processed. So you just hit the button and everything happens for you. And that's what the scale does. There's an input data sheet, and again, in the yellow is where you'll put your cursor, and it's where the scale will send the data. You'll hit input data, and it'll pop up in another sort of behind the scenes table, and you'll start the calculations. These are buttons that are available on the Excel program. The weights then are automatically sorted. This is, again, all behind the scenes sort of thing, and it takes the largest 10% of the population. Okay, that's identified and it's averaged, and then each weight, each single fruit is compared to the largest 10%. And any fruit that will be smaller than or 50% the size of the largest top 10% is predicted then to upsize. So those predictions are automatically calculated. They show up at the bottom of that sorting page. And this is where we use the same concept that Dwayne Green developed in the model, okay, with respect to a fruit that's 50% smaller, the size or smaller than the largest fruit will upsize. And it's based on the number that the prediction is based on the number that have already upsized at a sample date and the number that are predicted to upsize. And that's it. Those data then go into a figure, and this is sort of what you see on your home screen. And you have a predicted fruit set, you have your target fruit set. And if you were to put a second thinner on, you will add the new thinner date in that yellow box in the beginning, and then it will recalculate in days from the last thinner date. So again, remember that we will have all of this in a Fruit Quarterly journal with respect to the model procedure. The data, as I showed earlier in the first slide, can be found in our Hort Science, or Journal of American Society of Hort Science publication. As Terrence mentioned, we've also kind of been working alongside with Vivid Machines, and in this case, we used River Ridge Farm, or River Ridge allowed us to work on their site in Michigan. We did a series of different cultivars. This was in collaboration with Emily Lavely at MSU in Extension. And what we were attempting to do here is basically use our model to validate the Vivid machines model of fruit set prediction. And the far two columns, the vivid fruit prediction and the actual fruit per tree, or the FSDM, that's our prediction, the third from the last. You see at the last date, in this case, 9 days after thinner for Gala, there was a little bit of a difference with respect to the different models, but as you go down, Honeycrisp, Ambrosia, Fuji, there was really good similarity between the vivid prediction, the actual fruit per tree, and our prediction. So we were pleased to see that. Another part of this work, which we'll be submitting Laura's second chapter for publication this month, was a really cool concept where every sample day, we selected the 10th, the 50th, and 90th percentile Gala and Honeycrisp fruitlets. This was by weight. We analyzed those, or Laura did, for their non-structural carbohydrate content. And then we used a fruit size distribution model of ours to estimate the fruit setting fate of each one of these fruits, so that we could then relate the carbohydrate content in real time of these fruitlets to their predicted abscission rates. This is just an example of one cultivar and 1 year of the work. The red are the non-thin, the blue are the thin treatments, and a Malleusson model is below. And the data really did a fabulous job of supporting the validity of carbohydrate deficit and surplus on fruit abscission. So I won't belabor that, but we will be publishing those findings for Honeycrisp and Gala over a few years. Again, we'll submit that paper this month. And that's all. Pretty brief. I appreciate the attention, the opportunity to work on the project, and I guess if there are any questions, we'll take them.